Hi, my name is Jennika. I'm a PhD candidate in Dr. Javeria Hashmi's lab, and my presentation today is titled Working Memory and Post-Traumatic Stress Contribute to Different Chronic Pain Symptoms, but Share a Common Pain Modulation Mechanism. I don't have any relationships with financial sponsors to disclose, nor do I have any sources of bias to mention. Okay. So chronic pain is a heterogeneous condition, and in many cases, it's not fully explained by tissue damage. So due to this, treatments are often not effective in this population. And further complicating our understanding of the disease is that the neural mechanisms that underpin chronic pain remain unclear. So chronic pain itself consists of sensory and affective dimensions. So sensory pain refers to the physical characteristics of pain itself, so things such as the pain severity and the disability associated with the pain, whereas the affective dimension refers to the emotional and psychological experiences that commonly accompany pain. So this refers to things such as depression and anxiety. Now, importantly, these dimensions can dissociate. So individuals can experience high affective pain, but low sensory pain, and vice versa. So chronic pain is associated with many comorbid features such as trauma exposure, post-traumatic stress, and impaired working memory. However, whether specific factors are related to different dimensions of chronic pain is less well known. Previously, we've shown that post-traumatic stress symptoms are linked with the affective dimension of chronic pain, and in another study, we found that impaired working memory is linked with the severity dimension of chronic pain. However, exposure to trauma has been linked to both of these dimensions. So all that said, it remains unclear whether these dimensions are entirely independent or whether they share a common underlying mechanism. So one candidate mechanism is pain modulation. Pain is not determined solely by incoming sensory input, but it's also shaped by affective and cognitive processes, including threat appraisal, expectations, and prior experience. So research has suggested that both the sensory and emotional dimensions of pain can influence how pain is modulated. So one pathway that's strongly implicated in this process is the connection between the dorsolateral prefrontal cortex, or the DLPFC, and the periaqueductal gray, or the PAG. The DLPFC is involved in higher order cognitive control and appraisal, whereas the PAG is a major hub for descending pain modulation. And together, this pathway integrates top-down expectations with bottom-up nociceptive input to shape the pain experience. And further supporting this idea is that we've previously found that functional connectivity between the dorsolateral prefrontal cortex and the ventrolateral periaqueductal gray was associated with both post-traumatic stress and chronic pain severity. So all that said, here we wanted to determine whether chronic pain dimensions show distinct associations or similar associations with trauma-related symptoms and cognitive function, and we also wanted to test whether these dimensions share a common underlying behavioral and/or neural mechanism. So for the study, we recruited 159 participants with chronic pain. 124 of them were women with a mean age of 42 years. To assess working memory, participants completed a visual NBAC working memory task, and participants also completed several clinically validated questionnaires assessing trauma exposure, post-traumatic stress symptoms, and chronic pain outcomes. To assess pain modulation, participants completed a heat pain task where cues created expectations about the intensity of an upcoming painful stimulus. We then examined bottom-up prediction error, which reflects the mismatch between the expected pain and the actual sensory input received. So this is a useful metric for pain modulation because pain modulation requires the brain to continuously update expectations based on incoming sensory information. So larger bottom-up prediction error responses reflect an inability to adaptively regulate pain when sensory input is violating the expectations. Okay. So moving on to the results, first we examined whether these dimensions might share a common underlying mechanism. And we found that increased resting state connectivity between the DLPFC and the ventrolateral PAG was not directly associated with pain outcomes, but instead indirectly influenced both pain severity and pain affect through pain modulation. So specifically, greater connectivity between the DLPFC and the VLPAG was associated with increased bottom-up prediction error response, which in turn was associated with higher pain severity and higher pain affect. So this suggests that pain modulation represents a shared mechanism linking the neural circuitry to the multiple dimensions of chronic pain. Next, we examined how trauma-related and cognitive factors relate to these dimensions. So we found that trauma exposure predicted both post-traumatic stress and impaired working memory, However, post-traumatic stress was independently associated with the affective dimension of pain, whereas working memory was independently associated with the severity aspect of pain. And together, this suggests that chronic pain may be represented by two semi-orthogonal dimensions, reflecting different downstream manifestations of a shared upstream vulnerability, namely trauma exposure. While these dimensions are behaviorally distinct, they appear to converge on a common underlying neurological and behavioral mechanism, namely pain modulation. Okay, so in summary, these findings suggest that chronic pain is not a unitary experience, but instead is represented by two semi-orthogonal dimensions. And despite this distinction, both dimensions appear to arise from shared upstream vulnerability and converge on common underlying mechanism of pain modulation, which is supported by DLPFC PAG circuitry. And together, this supports a shared model in which distinct psychological processes shape different aspects of the pain experience while being unified by this shared neuropsychological pathway. And these findings highlight pain modulation as a potential transdiagnostic treatment target, while also supporting more personalized approaches based on distinct psychological pathways. Here's my references. I'd like to thank the members of the Brain Networks in Neurophysiology Lab. And that's all.